Okay, we are going to talk about your revision MCQ paper on the motion in a straight line lesson. That means your second lesson. The first question asks you to find out the scalar quantity. As you all know, the displacement. So, what scalar quantities and vector quantities are? First of all, scalar quantities are the physical quantities which contains only a magnitude, and the vector quantities are the physical quantities which contains both a magnitude and a direction. So when you talk about this question, it asks us to find out the scalar quantity. Displacement is a vector, as you know, it has a direction. Velocity is still the same, a vector. Weight, a vector, and mass is the answer. Okay, it has only a magnitude, no direction. That means a mass is a scalar quantity. So second question asks us to find out the vector quantity. So the way you have learned, distance is a scalar quantity, so that's wrong. Speed scalar, temperature has no direction, so it has it is a scalar quantity. Acceleration is a vector quantity. Okay, so then the next question, right? The next question, it says us the object is traveling to east. Okay, so let's mark this is north, this is south, and this is east, and this is west. So from a starting point, the object, let's say this is the starting point. From this point, the object travels 40 meters towards east, 40 meters, and it says that the object comes back along the same pathway to the starting point. So then that becomes the finishing point as well. So the starting point and the finishing point of this journey is equal. It has traveled to 40 meters, it has traveled 40 meters to east, and then from there itself, it has traveled back again 40 meters to the starting point. So you would obviously know the distance traveled by this object, the total length traveled by this object is 80 meters. And if they ask us for a displacement, you can obviously understand the displacement is the shortest possible linear length between the starting point and the end point, and that would be 0 here, because the object finishes its journey from the point that it finished the journey, started the journey. The object finishes its journey from the place that it started the journey. So there will be no linear length between the starting point and the end point of this journey. So distance of the journey is 80 meters, and the displacement of the journey would be zero. Displacement of the journey would be 0. Right. The fourth question. Train travel the distance of 40 kilometers within 2 hours. Then they are asking us to find out the speed. As you all know, the speed is equal the distance traveled by time. Distance traveled by time. Distance, what they mention is 40 kilometers, and time is 2 hours, right? 2 hours. So then when you divide it by 2, you get 20 kilometers per hour. So that is the answer. This is not the answer. 20 kilometers per hour should be the answer. 20 kilometers per hour. So this one is supposed to be the answer. Then they are asking us to find out the select the correct are they asking us to find the correct answer? Sorry. Speed is equal to the area under the distance time graph. Okay, if you can remember the displacement versus time graph, is it? So distance time graph, distance versus time graph. Now it's similar as the velocity over time graph. Okay, so velocity over time graph, sorry, displacement over time graph, right? Speed is equal to the air. Now if you can remember in a velocity versus time graph, the surface area under the velocity versus time graph was equal to the displacement. If it was a displacement, so if it was a velocity versus time graph, the area under the velocity versus time graph is equal to the displacement. So in velocity versus time graph, we have not learned the area under the velocity curve, displacement curve, or the distance curve is equal to anything, right? The gradient of the displacement versus time graph is equal to the acceleration. Okay, so there's no teaching for you. The speed is equal to the area under the distance versus time graph. That's wrong. That's wrong. Okay, that's very wrong. And when you talk about velocity is equal to the area under the velocity time graph. If it was a velocity versus time, the graph, the curve of the graph would be indicating the velocity, not anything under the velocity curve. You should have to consider take about the velocity. The curve of the graph would be itself would be indicating the velocity. So that's also wrong. Go to the third one. See, displacement is equal to the area under the velocity time graph. Yes, that's very true. If you consider the area under the velocity versus time graph, the area under the velocity versus time graph, that is clearly indicating the displacement that the object travels. That's very true. So that is the answer. So as we have learned, the gravitational acceleration was found by Sir Isaac Newton. Okay, we are moving to the seventh one. The magnitude of the gravitational acceleration, we consider it to be 9.8 ms minus 2, but for our calculation we round it off to 10 ms minus 2, if you can remember. And the gravitational acceleration is symbolized with simple g. Right, the next question, eighth question. A ball is thrown upward from the ground level and took 6 seconds to reach the highest point. What is the velocity of the ball at its highest point? Right. Okay. Now, in this case, what you have to understand, this object is thrown vertically upwards under the gravitational acceleration. So you have the ground level here like this, and the gravitational acceleration is considered to be 10 ms minus 2. That means any object which is vertically thrown upwards will be pulled towards the ground with a gravitational acceleration of 10 ms minus 2. So they say us the object is initially thrown at a velocity. Okay, they don't tell us the initial velocity of the object, but if it was to now, as you all know, if any object is propagated or projected vertically upward away from the ground, the object's velocity would be gradually decreasing 10 by 10, right? The velocity of the object has to be gradually decreased by 10 by 10 by 10. So then if this object has actually traveled for 6 seconds, it should have initially projected with an initial velocity of 60 ms minus 1. Okay, 60 ms minus 1. So then, guys, this object would have traveled. This is at the 0th second. This is at the 0th second. So at the first second, this object should have reduced its velocity up to 50 ms minus 1. Then the object should have reduced its velocity up to 40 ms minus 1. Then the object should have reduced its velocity up to 30 ms minus 1. Then the object have reduced its velocity up to 20 ms minus 1. Okay, first, second, third, fourth. Fifth second, the object should have reduced its velocity to 10 ms minus 1. Actually, at the 6th second, the object should have gained a velocity of 0 ms minus 1. Now, other than that, the object has no velocity. That means it can't go further. It can't go beyond that level. That means the object's velocity became 0 ms minus 1. It had an initial velocity of 60 ms minus 1. From there, the object's velocity reduced up to 0 ms minus 1 within 6 seconds, right? So thereafter, the object has no velocity, so then object cannot move further, right? That's the maximum height that the object would travel. Okay, so this is the maximum height that the object would travel when it is moving vertically upwards against the gravitational acceleration. So what you have to understand is the object would be the velocity of the object at the 6th second would be 0 ms minus 1. What is the speed of the above ball at the highest point? The same thing, no, the same thing, right? Speed also 0 ms minus 1. What is the speed of the above ball when it reaches the ground level? Exclude the air resistance. That means it asks us to, how can you understand if anything is falling onto the ground from the sky, right? The velocity of the object would be reduced by the air resistance. As have you all know, like if a person falls down freely from the air towards the ground, the velocity of the person when he is falling to the ground could be reduced by having a parachute, because the air will be resisting the downward motion of the man. Can you understand? So likewise, if any object falls onto the ground from the earth under the gravitational acceleration, the motion of the object would be resisted by the air resistance. So here they ask us to exclude it, forget it, do not consider it, right? So then they are asking us if an object falls, the same object which was thrown vertically upward for 6 seconds, if it falls to the ground again, they're asking us to find out the velocity of the object when it hits the ground. So now, if you can remember, at the 6th second, the object had no velocity, 0 ms minus 1. No, now we are calculating. It is coming towards the ground. So let's consider this to be the 0th second. Okay, when it is coming from the top to bottom, again 0. So then the first second, it should now it is accelerating towards the ground now, right? Because it is now coming towards the ground. Gravitational acceleration supports rise motion, right? So when it comes down towards the ground, the velocity of the object increases up to 10 ms minus 1 in the first second. Second, the velocity of the object increases up to 20 ms minus 1. Third second, the velocity of the object increases 30 ms minus 1. Fourth second, the velocity of the object increases up to 40 ms minus 1. Fifth second, the object of the velocity increases up to 50 ms minus 1. The sixth second, when it hits the ground, the velocity of the object would be 60 ms minus 1. So now you can understand what is the velocity of the object when it hits the ground. That is 60 meters per second. So there you have two answers, 60 kilometers per second and 60 meters per second. 60 meters per second should be the answer. Okay, so we are moving to the 11th question, right? Okay, you have a triangle. The object should have started its journey from point A, and then object should have ended its journey from point C. So it has traveled from point A to point B 6 meters, and from point B to point C for 8 meters, right? So they ask us to find the distance traveled by the man. So obviously you can understand the distance from the point A to point B, that is 8 meters. From point A to point B, that is 8 meters. Sorry, 6 meters. I'm sorry, 6 meters. And from point B to C, 8 meters, right? So it has to be like 14 meters. The total journey has to be 14 meters. And they ask us to find out the displacement. So if you see here, point A is the starting point, right? Start. Point B, point C is the end point, finish. So the distance of the object is from A to B, B to C. But they are asking us to find out the displacement. Displacement is the shortest possible linear length between the starting point and the end point of a journey. So in this case, the starting point is A, end point is F. So displacement could be found out of this motion by calculating the length of the hypotenuse. So how do you do that, right? Apply the Pythagorean law, right? Law of Pythagoras. So that would be simply A C square will be equal to A B square plus BC square. Okay. So we know AB square is 6 square, BC square is 8 square. So 36 and 64, that will be simply 100. 100 will be equal to AC square. So then to find out the AC, you need to put the square root to 100. So AC would be 10 meters. All right, AC would be 10 meters. So you definitely get the answer over there. That's 10 meters. Okay. This is the answer. All right. 13th one. Object projects upward with a velocity of projects upward at a velocity of 50 meters per second. What is the time taken by the object to reach its maximum height? Okay, the same question what we answered before, right? It is vertically thrown against the ground, against the gravitational acceleration, because gravitational acceleration is vertically acting downwards. So the object is thrown initially with the velocity initial of the object was 0. So they say as 50 ms minus 1. This is at the 0th second, right? First second, the velocity of the object reduces up to 40 ms minus 1. Second, the velocity of the object reduces up to 30 ms minus 1. Third second, the velocity of the object reduces up to 20 ms minus 1. Fourth second, the velocity of the object reduces up to 10 ms minus 1. Fifth second, the velocity of the object reduces up to 0 ms minus 1. What do they ask us from? If the object was if the object was projected with a velocity of 50 ms minus 1, how would it time to reach the maximum height? So as I told you, once it reaches 0 ms minus 1, when it is going vertically upwards, thereafter the object cannot travel any further above, because the velocity of the object has reached 0. So that is the maximum height that the object could travel. So then to travel the maximum height, the object takes 5 seconds. 5 seconds. So then they ask us to find out the maximum height of the above object reached by the above object. So then here what you have to do is to calculate the displacement. So as you all know, velocity equals displacement divided by time, subject displacement, that is velocity into time. Now in this case, there's no constant velocity. The object has a variated velocity. So then you'll have to calculate for average velocity. So find out average velocity and multiply it by the time taken for the motion of the object. So how to find out the average velocity, right? Velocity initial plus velocity final divided by time would divide by 2 would be the average velocity and multiplied by time. So what is the initial velocity? That was 50 ms minus 1. What is the final velocity? That is 0 ms minus 1 divided by 2 and time taken for the motion 5 seconds. So when you simplify, 50 divided by 2 is 50 divided by 2 is actually 25 meters per second. And when you multiply it by 5 seconds, plus seconds to minus seconds goes off, and 25 into 5 is 125. So the object travels for 125 meters. Okay. So that is the answer. So the object travels for 125 meters. Right. What is the assumption that you need to take calculating the above two sums? Okay. So when you're doing this, as you can remember, we have to neglect the air resistance, because the air resistance would not let our velocity of the object to remain this exact same values, because they will also add a resistance to these velocity variations. So then exactly you can't calculate the velocities like this. There could be variations other than your assumptions, right? So what you have to do, there was no rain. That actually there's no direct effect from the rain for our calculations, so you can just avoid it. There was no air resistance. That is what you have to consider. You have to consider that there was no air resistance. That is what you have to consider. Let's go to the other answers as well. The object has not thrown directly in the direction of the sun. No, that's not a matter. That's not a fact that affect calculations. The object was spherical one. That is also not much of an effect caused by the shape of the object. There is an effect caused by the shape of the shape of the object, but we don't have to consider that. So the air resistance is absent. That's what you have to consider, right? Okay. So then 16 and the 16 to 20 are based on the graph that they have given. So when you look into this graph, this is a velocity versus time graph. So then let's quickly mark what they have given. Within 10 seconds, the object has reached 40 ms minus 1 of a velocity. Okay. So within 10 seconds, the object has reached 40 ms minus 1 of a velocity. And then actually, the object has traveled in the same velocity of 40 ms minus 1 until after the 20th second from the 10th second, and then object has reduced its velocity to 0 ms minus 1 when it reaches the 25th second. Right. Okay. What can you say about the acceleration of the object during the first 10 seconds? Now see, at the 0th second, the velocity of the object is 0. Within 10 seconds, the object has increased its velocity up to 40 ms minus 1. That's an acceleration, obviously. That's an acceleration now, right? So they are asking us what would be the acceleration. So then let's find out the acceleration. Acceleration equals velocity final minus velocity initial divided by time. Velocity final of this within the first 10 seconds is 40 ms minus 1. Velocity initial is 0 ms minus 1. The time taken for the velocity change is 10 seconds. So then 40 ms minus 1 divided by 10 seconds. So plus second to minus second cuts off that. Sorry, not they are not getting cut off, right? I'm sorry, right? Right. So then what would be the answer? 40 divided by 10 is 2 ms minus 2 would be the answer. So the acceleration is uniform and it is 4 ms minus 2. That is the answer. What can you say about the motion of the object during the 10th second to the 20th second? So see here, at the 10th second, the object's velocity is 40 ms minus 1. 20th second also the object's velocity is 40 ms minus 1. So during this during this time from the 10th second to the 20th second, the object has the same velocity. So which means the object is traveling at a uniform velocity. Object is traveling at a uniform velocity, right? The next one, 18th one. what is the total displacement? Okay, so you can find out the total displacement of this journey. As you can remember, the velocity time graph, when you are indicating the data of a data in a velocity versus time graph, the area under the velocity versus time graph gives you the displacement of the object. The area under the velocity curve of a velocity versus time graph tells you the displacement of the object. So area equals displacement. If this was a velocity versus time graph only, yeah. Okay, so then how to find out the displacement? So you have to find out the displacement of a trapezium. Okay, so then you would find the displacement traveled by the object A plus B divided by, how to find out the area of a trapezium? A plus B divided by 2 into perpendicular height. What is A plus B? A plus B would be the parallel, A and B would be the two parallel lines. So the length of the first parallel line is actually you have to substitute it with units. The length of the A is 10 meters, 10 seconds. Okay, 10 seconds. The length of the B is 25 seconds. Divided by 2, perpendicular height is 40 ms minus 1. Okay, so this is 20. Okay, 10 plus 25 is 35, isn't it? 35 seconds into 20 ms minus 1. So it's going to be 140 meters plus second and minus second cuts off 140 meters. Okay, that's how you get the answer. I'm sorry, there is an error in calculation. Sorry, yeah. 35 into 2 is 70. I'm sorry, 35 into 2 is 70. And it has to be multiplied by not by 2. It is actually by 20. So it has to be 700. I'm sorry, yeah. 700 meters. So that's the answer. 700 meters. Sorry, yeah. Sorry. 19th, what is the deceleration of the object during the last 5 seconds? As you can see, during the last 5 seconds, from the 20th second to the 25th second, the velocity of the object at 20th second is 40 ms minus 1, and the 20th second, the velocity has dropped, 25th second, the velocity has dropped down to 0 ms minus 1. So then you can find out the deceleration. Velocity final minus velocity initial divided by time. Velocity final is 0 ms minus 1 at the 25th second. Velocity initial was 40 ms minus 1 at the 20th second. The time taken for the velocity change is 5 seconds. So you get minus 40 ms minus 1 divided by 5 seconds. Actually, since they are asking us a deceleration, you don't want to mention the negative value. So it has to be 8, right? 8 ms minus 2 would be the deceleration. Right. Right. So then you should have the answer here. That is 8 ms minus 2. That's what your answer is. What is the acceleration between the 10th second and the 20th second? So consider here acceleration from the 10th second to the 20th second. As you can remember, 10th second the object's velocity is 40 ms minus 1. 20th second the object's velocity is 40 ms minus 1. So from the 10th second to the 20th second, the object has no variation in its velocity. The object travels with the same velocity, right? So then the acceleration will be 0 because the object is traveling at a uniform velocity, constant velocity. It is not increasing its velocity or decreasing its velocity. It is traveling with the same velocity. So the acceleration of the object would be 0 ms minus 1. There's no acceleration. So that's how we finish the discussion of this lessons in revision MCQ.